This is an example of an indeterminate product. So basically I have this as x goes to negative infinity, clearly x goes to negative infinity. And the ln of 1 minus 1 over x, let's see, this would go to 0 as x went to infinity, positive or negative, and the ln of 1 is 0. So this is the indeterminate form, negative infinity times 0. So I can apply L'Hopital's rule. However, I need to turn it into one of the other forms. What I will do is rewrite this. Instead of x multiplication, let me rewrite top as 1 minus 1 over x. And I'm going to divide the whole thing by 1 over x, because dividing by a fraction is the same as multiplying by the reciprocal, and the reciprocal of 1 over x is x. So these two say the exact same thing. Dividing by 1 over x is the same as multiplying by x. Now I have the indeterminate form of 0 over 0. Because, again, as ln of x goes to infinity, this goes to 0. 1 minus 0 is 1. The ln of 1 is 0. And on the bottom, as x goes to negative infinity, this goes to 0. So L'Hopital's rule apply. I will now take the derivative of the top and the bottom separately. So the derivative of ln of anything is 1 divided by whatever that anything is. And again, I have to apply the chain rule times the interior and the derivative. Let me illustrate what I am taking the derivative of. I'm now taking the derivative of just this component on the inside. And the derivative of that is, the derivative of 1 is 0. The derivative of negative 1 over x is positive x to the negative 2 power. If you need to see that out to the side, I will be happy to show you. The derivative of negative 1 over x equals the derivative of negative x to the negative 1. Power rule, multiply, gives me positive 1 times x, subtract 1, gives me negative 2. So that's how I got that x to the negative 2. Which means on the bottom, I'm going to do the same thing, except for it's going to give me negative x to the negative 2. Now, and again, the derivative of 1 over x is going to be just the opposite sign. Positive, positive, opposite sign is negative. That means this top and bottom reduce out. However, I'm left with a negative 1 after I've done my reduction. I'm going to rewrite that by distributing the negative 1, and I can really do it anywhere. The easiest place to do it is make everything on top. I'm just flipping the sign in the denominator on top. So I have 1 over x minus 1. And that's what happens when I distribute a negative x to the denominator up top. Now, this I can evaluate very easily. The top goes to 1. The bottom, 1 over x, as x goes to infinity, goes to 0. Minus 1 gives me negative 1. So again, L'Hopital's rule, little algebra, gets me my limit.